let's talk about fusion. All right, let me set this up a little bit. We'll go to sort of a quick physics class. So fusion fusion is this high-speed collision between two atoms, causes them to merge, and it creates this enormous amount of energy. We've understood this for a long time. The thing we've been trying to figure out, the thing scientists have been trying to figure out, I say we, I don't mean we, I mean them, is how to do this in a way that creates more energy than is required to sort of make it happen. Because if they can, this could be a source for all kinds of solutions to energy crises, to climate change. I mean, the byproduct of these things is water. So this week, the U.S. Department of Energy announced that scientists at Lawrence Livermore National Labs, which is right outside San Francisco, they've managed to do this. They've created more energy than they used up in one of these reactions. And it's a massive step towards this kind of energy revolution. There's a million caveats. It could be decades till they sort of make it efficient. But one of the things I think is most interesting about this is that the biggest obstacle that they're going to run into is the fuel that's required to make this thing happen. So again, we're in physics class just for one more moment. Takes two hydrogen isotopes to make it happen. One is called deuterium and one is called tritium, right? So deuterium's everywhere. It's in your glass of water that you're drinking right now. Tritium is extremely rare. Some of it, when you do like a nuclear, if you're in like a power plant with a nuclear reactor, you can get some there. You might catch some when cosmic rays break through the atmosphere. Otherwise, it's pretty rare. However, what there's plenty of is a helium isotope that's called H3. And that can easily either create tritium or you can take two H3 molecules and crash them together. It's abundant, but not on Earth. It's abundant on the surface of the moon. There's just a ton of it. So in other words, moon mining might at the end of the day be the key to saving the planet in all the ways that people are talking about. So now we come to the question, Russell, let me ask you, if by going to the moon, we could solve the climate crisis, provide cheap energy for the entire world, make a massive dent in global poverty, then what on earth is the founder of SpaceX doing, spending every waking moment trolling people on Twitter?
Well, yeah, that's a good question. I think one of the things that the scientists involved in this fusion advance keep saying is this is huge and not immediate. And so if you have your expectations up that this is going to immediately be the energy source we're going to have, then you're going to be disappointed. I heard one of them say, this is the Kitty Hawk. It's not the transatlantic jet yet. You've got to have the Kitty Hawk in order to get there, but that's right. What it is. And yeah, I mean, the questions I'm most worried about are not why doesn't someone like an Elon Musk come up with the technology to do moon mining well, if that's where we need to go? It's what's going to happen when you have international conflicts about, who owns the moon? There's an American flag on the moon because we were the first there. But how do you negotiate when you think about all of the tensions we have with really clearly defined boundaries on Earth, and you take that to the next level? That's going to be tricky. It's really going to be a challenge for the next generation.
Yeah, and there's even been some discussion. Going back, for a few years now, that part of potentially part of the current space race that's really going on between America and China is around these very things. The stuff that we could be mining in space, the stuff that the moon, asteroids, all the rest of it. And it doesn't seem unrealistic as more and more money and investment is happening along these lines.
Yeah. And again, similar to what we were talking about earlier, one of the issues that makes this so ambiguous is the fact that if you even talk about it right now, it sounds so science fiction-y and so unrealistic. And somebody would say, well, why would we worry about space colonization or mining of properties in other places when we have real issues here? The problem is then once these things become real, they're already set in terms of what the boundaries of them are. And that's what becomes really difficult.
Mm-hmm. When you think about a story like this kind of, incredible innovation, do you look at this and say, wow, this is a beautiful thing that humanity can do these things, that creation is made in the way that it is? Or I guess I should say, how much do you think of it in that way? And how much do you think of it in the way that's similar to the topic we were just discussing? This, literally this sort of Promethean, we are playing with fire, and who knows what the consequences of these things are? Because almost every one of these scientific innovations has come with terrifying consequences over time.
I actually have more of the first reaction, and here's why. Because I think that we're still in a Promethean moment in all kinds of ways of human life, but scientific enterprises tends to be the least given to that right now. Even though previously the most given to it. So there was a mindset that I think once came along with modern science that said, okay, we now understand and know the universe. Let's harness it and move forward. Now, the deeper one gets into physics and astrophysics and almost any other science, the more one realizes how mysterious the universe actually is. And that brings an inherent sense of limits. So I actually feel better about that than I would have at almost any other point in the modern era. And that's one of the reasons why, honestly, when I go onto a secular campus now, if 20 years ago, you would probably find the Christians in the English department. Now I'm much more likely to find Christians on faculties who are astrophysicists and biologists and otherwise. And part of that, I think, is this sense that we really know we're not in charge of this universe, and we really know there is so much we don't know. So I see this as being a good but cautious development, and especially because one of the ways when we look at climate, you're not going to be able, there's some things we can do in terms of regulation, but you're not going to be able to regulate your way out of this when you're dealing with China and India and so forth. And one of the points of resistance that so many people have had to say nuclear energy is, what do you do with the waste? And what do you do with potential meltdowns and dangers, even though those are rare? Well, this fusion energy promises an elimination of both of those problems. And so if that's the case, it actually is a huge advance for the safety of the planet and for impoverished people around the world.
Yeah, I agree. And I think the other part of it that I've found myself thinking about is just a bit of just sort of the wonder of creation of it all, right? Like the fact that inside of two atoms, you have this enormous amount of power energy that's ultimately it's incomprehensible for us. Like even you can see the numbers on the page, but they don't mean a whole lot. And I thought this week, reading some of the stories, I thought of this great story that Dallas Willard told years ago, that he had a conversation with a fellow professor at USC, religious skeptic, particularly skeptical about miracles. And one of the things he said to Willard was, this whole miracle of water into wine at Cana, like if Jesus had actually done that, the power of that, the power of that chemical reaction or the fusion or whatever, at a minimum, it would have melted the pots. It probably would have blown up all of Cana. And Willard sat there for a moment and he said, I think if he can handle the reaction, he can handle the pots.
Yes, isn't that the truth?
And so I do think it's a moment for awe. It's a moment for wonder and for sobriety, because realistically, my sense is that this is going to be a generations thing before it comes through. But it could be a real gift to the world if we're good stewards of it.